Hello to all friends and fans of the pulp, paper and bioproducts industries. Welcome to our exciting Spectrum podcast, where today we'll be talking to an Andritz expert about the benefits of the Shoe-Blade GapFormer for ensuring maximum dewatering and excellent formation on paper machines. I am Mark Rushton and I will be your host. When operating in a highly competitive marketplace such as papermaking, it is essential to maximize production. Enter Andritz with its Shoe-Blade GapFormer, which can be added to new machine configurations or retrofitted into existing paper machines. The patented design enables excellent strength and formation at a high capacity of up to 250 GSM. The Shoe-Blade GapFormer is ideal for fast and uncomplicated rebuilds, as the basics of the GapFormer are already installed. For example, frame and rolls remain unchanged. Andritz simply implements the Shoe-Blade technology in the forming area. With this GapFormer, it is possible to add another grade or to convert the former entirely into a different grade, for example, packaging paper. So today we are delighted to welcome William Lawrence, Global Product Manager, Forming, Paper and Tissue Division at Andritz, to find out more about the Shoe-Blade GapFormer. Great to have you with us, William.
It's a pleasure to be here.
Excellent. Okay, so let's go straight in. Can you please give us a profile of customers that would generally benefit from the installation of a Shoe-Blade GapFormer? What challenges does it solve?
Overall, the GapFormer as a technology has been pretty well established in the pulp and paper industry as a solution for two-sidedness, for high machine speeds, etc. But as time has gone on, the Shoe-Blade GapFormer kind of began as an evolution to that. And when we're talking about folks that are interested in reinventing their machine, we are looking for, and I think customers themselves will be looking for, folks that are reaching the limits of their existing forming sections. So be that in dewatering capacity, be that in strength, or they've reached the bottom end of their MD/CD ratios. Customers that are looking for flexibility and to decrease or to find more room in their production process is ultimately who I think will benefit from this the most. Folks with an existing bell bay that they've gotten to the end of life, or the end of they've reached the limits, or folks that with a roll blade GapFormer that are looking for something to improve their runnability and their ratios. So ultimately, those are the folks I think that will benefit the most from this. People that want to go into swing production. Folks that find their machine is not flexible enough. Those are the people that will benefit the most from this.
Okay, that's an excellent answer. Thank you very much. So, what opportunities does it bring? What does a Shoe-Blade bring as an opportunity?
Broadly speaking, the main benefits, and that can be summed up in the word of flexibility. When we consider what are some big limitations for an existing bell bay, for example. Impingement. Impingement's very, very inflexible. If you messed it up, you're going to be having a pretty nasty day. If you're looking at a roll blade former, you start running into limitations on basis weight limits. You start reaching those limits rather quickly, especially as you go up in speed, because as you exit the roll and you have some vacuum pulse, it's going to destroy your ply bond or your internal strength, and you could even notice defects in the paper itself. And so when you are looking to upgrade to Shoe-Blade former, both of those limitations, those larger limitations, are nearly eliminated. You don't have the impingement sensitivity for a Shoe-Blade former is, well, there isn't really any sensitivity. It's incredibly flexible. And then when it comes to basis weight, we don't have a diverging fabric pattern in that particular manner. And so you don't get that large vacuum pulse for destroying strength and limiting basis weight. There are a few other tricks up our sleeve that kind of limit the sensitivity that you might see on these other gap formers.
Okay, great. So can you tell us about Andritz's experience in the development of the Shoe-Blade GapFormer? It seems like you yourself even have a lot of experience in it.
From a Andritz perspective, it's our development. I mean, Andritz as a company has gone through many evolutions of this and the industry has overall. But from an acquisition standpoint, I mean, the folks that developed Shoe-Blade gap forming from the very beginning are part of Andritz now, and so from the very infancy of the the Shoe-Blade gap former on newsprint machines in Korea, for the last 25-ish years, maybe a little longer, the development has been not exclusively, but pretty darn from a majority perspective, internal to Andritz. So you'll see other aspects on the market, but the folks that developed that technology kind of came from not Andritz per se, but from the core team that developed it a long time ago. So our involvement has been, working with different impingement geometries, with different movements that allow greater flexibility, higher basis weights, lower ratios, etc. So from the very beginning, it's been kind of part of this team.
Okay, brilliant. So let's go a little bit more in depth. And how does the technology actually work?
I mean, it is a paper machine. Paper machines have been around for hundreds of years at this point, and so the core principles and fundamentals of paper making are not something we're looking to change, more just to take advantage of, right? And so when you're looking at how the technology works, it's not to necessarily invent something new, but to see where those limitations existed on other machines and to go beyond them. So, for example, when we're talking about making better paper, it's all about shear control and where we apply it. So, when you consider how that has been achieved with historical technologies like a bell bay, that has been done with parametrically oriented blades in a curved shape, and the blades themselves are oriented in a way that give pressure pulses and good dewatering. But pressure pulses also create machine direction alignment. And so if you're looking to achieve lower ratios, you want to have some kind of pulsation-free zone where you can work with the dewatering without trying to orient things in the MD direction. Well, you can do that with a roll. However, as you go up in, that region of pressure-free forming is it's limited entirely by the diameter of the roll. And, you can start with a really small roll, and then you find, okay, well, I want to have more gentle dewatering. Well, then you just go up and up and up in roll diameters, and eventually you just can't make a roll that big anymore. And so when you see those limitations and the opportunities of both of them, how do you combine them? Well, if you can create a impingement profile that is pulsation free at an equivalent diameter that's equal to or larger than the largest roll that's manufacturable, you kind of have a shoe. You can manufacture a small section of ceramic, relatively small, that is all that the paper experiences, and you're able to achieve equivalent diameters that are much, 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 much larger than what you could experience with a roll. And so that allows you to have more gentle dewatering. It allows you to eliminate those diverging nips. And then once the paper is set, if you're looking for formation, which is coming from blade pulses, then after you exit the shoe, that aspect still exists in the Shoe-Blade former. So we're not trying to change the paper making process per se, but we see that there's limitations that existed with the roll blade and the bell bay, the bladed formers, and we kind of took the best of both of them and put them together.
Okay, fantastic, comprehensive answer there.
I'm going to give one more thing too.
Yeah, sure.
When you go up in basis weight, that's the stock just gets thicker. You're putting more mass through a given space. And so when you are dealing with static geometry, that isn't very conducive to a changing stock thickness. And so one of those aspects of limitations that we found in older or traditional technologies is that it's a static geometry. It doesn't change. So by implementing into our design the ability to change the position of units relative to the stock, it allows us to get much higher basis weights without putting too much shear into it and crushing out in the forming section. And interestingly, you said up to 250 GSM. That's just all we've had the opportunity to produce. We haven't actually seen a limitation in the, not yet at least, where we are worried about the basis weight. We could probably do more. So if anyone wants to do that, then we'd be more than happy to work.
Excellent. Great. Thank you. So how does Andritz Shoe-Blade GapFormer compare to the competitors' offerings?
So ultimately, it's going to come down to the way we achieve our pulsation-free environment and the flexibility of the machine overall. So starting with number one, the dewatering environment early on, the stock is quite sensitive to pulsation and how the paper forms right then and there in the early parts. And so when we compare our shoe to those other options on the marketplace, we see that the way the geometry is achieved with our system truly is pulsation free. Whereas if we compare that to alternative designs, those are achieved with simulations of a curve using cross machine ceramics similar to you'd see on other vacuum boxes in the machine. And while it's clever and it works quite well, the problem is when you try and produce tighter and tighter curvatures, you start to see those pulsations come back into the machine or into the stock. You don't actually get rid of them. Whereas our profile, our dewatering system is arranged early on in such a way that you don't get those pulsations. And so that aspect is truly unique. And if you are trying to additionally have the flexibility of movement and static geometries like we talked about earlier, presently ours is the only one on the market that is as flexible as we make it. And so in terms of impinging at tighter geometries, having the position of units change, whether it's low basis weight, high basis weight, counter blades, etc., all of those aspects are completely customizable without having to deal with the compromises that come from a static environment.
Excellent. Thank you very much. So now more onto the operational side of things. So can you describe the hands-on experience of the former? Where is it on the machine and where is it installed? And is it a complicated installation? Tell us how easy it is to actually fit this.
So hands-on versus installation versus operation. Okay, so we'll start with installation. Installation isn't really any more complicated than installing or doing any large conversion. I mean, it's a big project for everyone involved, but if you're doing a conversion, you take everything down to the frames and you put everything back in. Not really. That's why we have a full engineering team to do that make that as painless as possible, just like everyone else. That it's no more difficult than putting in another kind of former. It just is different. And with operation, it's really easy and it's pretty nice. Everything is really in front of you. You can see how the jet impinges. You can see what the cut. You can see what the cut through looks like through the vacuum wire. You can see where the water is going and conversely where it isn't going. For example, you can easily manage water handling, and you can see where the wet and dry line is. No issue. We try not to hide anything from the paper maker because we understand that it's important to be able to get out and put your hands on. So I guess the ending being it's completely up to how the machine owner wants to have it be. We can have it be adjustable on the machine directly, where it's right in front of you, which is pretty standard, or just in the control room, which is also standard. Both options are available, and the hands-on experience is really quite nice. You can really get up into the process and see what's going on, or be comfortable in the air conditioning.
Excellent, William. Can you, one of the advantages, of course, is being able to switch grades. So can you tell us a little bit about doing that and about how easy it is?
I mean, swing operation is incredibly simple here. I mean, running a swing machine in any situation, it's challenging. I mean, that much is kind of reminiscent of back in the good old days where you could run anywhere, you could run anything on a Forgineer. Nowadays, folks are looking to run anything on a GapFormer, and I do think the Shoe-Blade technology is well positioned for that due to its flexibility, and primarily because of that flexibility. And so, recently we had an installation where we're able to run anything from newsprint and 30 gram all the way up to a 100-gram liner board. And, other than the color of the fiber, you can switch grades in no time at all. I mean, this stuff is truly applicable to making a successful grade change. To be able to adjust your gaps in your impingement locations can mean the difference between making newsprint or 150-gram liner board. I mean, it's
Yeah.
that level of flexibility is nearly unheard of in any other kind of.
It's one of the key benefits, basically, isn't it? The next question is, what are the environmental benefits of the Shoe-Blade GapFormer?
Chemistry and wastage, energy to some degree, but I would say lost quality and chemical usage. I mean, from a fiber standpoint, if you're looking to get the most out of your fiber, this is really this is how you do it. You're able to, in terms of PMPI, or the Paper Machine Performance Index, we're able to achieve, upwards of 90% of the strength of the machine chest is able to be preserved on the Shoe-Blade GapFormer, which compared to other types of formers, you're talking 70, 80%. How do you make that strength up? Well, you can do it with a size press and starch. You can do it with strength. You can, et cetera, et cetera. But when we are considering like reduction of chemical usage, if you have to reduce your chemicals, you have to preserve your strength. And when you're discussing broke, the less off quality paper you make, of course, the less broke, the less wasted product you're sending back into the process. Both of these aspects are able to be mitigated on a Shoe-Blade former, because you're able to promote higher strength, you're able to achieve better formation, you're able to have lower NVCD ratios, and the CD characteristics of it are excellent as well. So you reduce the amount of wastage, you reduce your amount of strength chemicals that are added.
Excellent. And the next question I have here for you is, can you tell us about any case studies or references of customers running with the Shoe-Blade GapFormers? What sort of results have they been achieving?
A lot of our customers are really driven by, or technology driven. They want to be in a position in a marketplace that is able to do what nobody else is doing technologically. And so I can think of, 3 references at the moment that are 4 references really that are applicable. And so let's say one in Australia that is pushing more than 10 tons per hour per meter of machine width, which is exceptionally high specific production and world class. We have another machine that is working on producing the first TMP based liner board in the world, taking advantage of the high stiffness and being able to be successful in the marketplace with that product, while also making newsprint. So liner board newsprint, that's that swing operation we were talking about earlier. And additionally, when we're talking about high basis weight performance, one installation that we have in the US is able to make upwards of 250 grams in a single ply. So, I mean, most other roll blades or technology is going to have to combine those 2 plies to be able to get basis weight that high. whereas we're able to sling the stock through the shoe-blade former without really too much challenge. And then, for example, we have our installation, a recent installation in Austria. For example, all the shoes that we've been supplying historically have been ceramic shoes. It's very traditional material to use in the forming section as a wear surface, but and folks have experimented with stainless steel products in the forming section before and have thus far been unsuccessful. But the material it's very attractive because it's low cost, and shoe blade conversion isn't necessarily the world's cheapest endeavor. So we were able to achieve a very successful stainless steel installation in a craft liner or a craft facility, not necessarily a craft liner, at the same profile as our ceramic shoe, and have very good results in terms of wear and runnability. So that technology is going to be coming soon to a paper mill near you.
Excellent, William. Thanks again for a comprehensive answer. And final question to you here is, anything new coming up in the future for paper-making technology at Andritz?
From an industry perspective, I really do see the industry moving more towards swing operation and I said this earlier, and it's an opinion, but take it for what you will. And so with that in mind, and also the experiences we have with the shoe-blade former, I still see the technology in its infancy. And right now, we've been very successful in the marketplace with only a few different shoe configurations, only a few different shoe designs. But changing those designs is something that we've really looking to do with different customers, to be able to optimize the shoe curvature specifically for each individual installation, for example. So that way everyone is able to have a shoe profile that's engineered for the grade. We're looking at different materials to be able to put into these applications to have both the CapEx and the OpEx be more minimal than it has been in history. And ultimately, these two aspects, changing the curvatures, new materials, are really what's opening the doors for us, I think, in going forward in the futures, to promote this need for swing operation and for other more, call them, specialized grades.
Excellent, William. Thank you for an excellent discussion. And thanks for sharing your immense knowledge on the shoe blade. Thank you very much. Clearly, Andritz knowledge and dedicated technology across the whole paper-making process gives producers an advantage when it comes to producing top-quality paper products. The Shoe-Blade GapFormer is a prime example of how Andritz enables paper and board producers to optimize production efficiency, dewatering, formation, and paper strength, as well as providing maximum flexibility. Many thanks to you, William, for an excellent and comprehensive discussion.
My pleasure. As always, the time is minimal to try and communicate everything in a short period of time.
Brilliant. If you're interested in learning more about the Andritz Shoe-Blade GapFormer, you can find more information in the show notes of this podcast. And thanks to our valued listeners. Goodbye.